Today we are going to review the principles or the basics of C++ language, and we are going to use the reference mentioned in the first line. You can check it if you want to have more details about C++, but I will mention in this lecture the basic things that we are going to use in this course. So basically, you can think about C++ as a superset or like enlarged version of C. So basically, C++ is an extension for C. You can think of it like this, but it's another language. I mean, it has its own way, its own compiler, but it supports everything we have in C. So you already know, for example, pointers, operations, for loops, control loops. You already know this stuff, right? Somehow.
Oh,
Yeah, but the same, you can use it in C++. And it's originally from 1983, invented in 1983, and the roots even older than this date. The main thing, why it's called C++, why it's C and then two pluses. Actually, because it has more features than C. That's why they call it C++. It's like the plus version of C. It supports the main feature that it supports orientation, object-oriented programming. The term, you know the term object-oriented? Yeah, it's classes and yeah. So the main thing in C++, besides the other features, is supporting the object-oriented programming, which is not supported in C, originally C. In C, you cannot define classes. And C++ now is used in different fields, almost all fields except web, I think. So you can use it for desktop application if you want to make a GUI and a complete application, like the one you use at Notepad++ is, I think it's written in C++. Also for device drivers, most of the drivers you use in your computer is written in C++ because it's efficient. It's the language itself is efficient. I mean by efficient, it's speed. If you compare the same program, the same functionality between, let's say, Python and C++, mostly C++ will be faster than Python, for instance. That's why you use it for low-level programs like device drivers. Also, it's well used in embedded system development. I mean, like writing programs for electronics devices, small devices. So it's well used also for servers and network applications. For video games, also it's well used also. So you can see it's used in almost all fields in computer engineering. And a good thing to start with when you think to learn a new language is to see how much it's used in the job market or in the real life. So one of the most famous reviews or surveys indicating how important or which best languages now famous in the market is this is the review or the survey done by IEEE, which is one of the famous institute for electronics and electrical engineering. And you can see that C++ is the fourth. This is for 2021. And C++ is the fourth language in popularity. And in some instance or in some scenarios, maybe C++ is the most important one. For example, if we go to this survey, you can see a language like Swift. Where is Swift? 12? Yeah. Yeah, 10. Swift is the language used for iOS development application, the mobile application for iOS. But this list is 10. But if you were an iOS mobile developer, it will be for you the first language. But in addition to this, C++ is in the fourth order of this list. So this is like I think we should take into consideration when we want to learn any new language. Yeah. And again, the history, I will not go through every stage, but I just need to drag your attention that C++ started from 70s and has multiple versions. And you can see that, for example, here C++ version 2, and then C++ 98, and then C++ 03. So almost each 2 years or 3 years, you have a new version of C++. It supports the old features and add the new features. And each version has a name, unique name, and mostly it's the last 2 digits of the year of release. So in 2014, there was C++ 14, 17, C++ 17, and most recently is C++ 20. Here in this graph is being developed, but it's already released. So let's start by hello world in C++. How we write a simple program. In all languages, the first program we do is writing hello world. So if you are familiar with C, it has the same structure. You have include. You should include your main library. So you use the syntax or the keyword include, hash, and then include. And then the name of your header file or your library. So as long as we are going to print a sentence, so we need an output. We need to make an output. So we are going to use the IO stream, which is input-output stream library. So first thing is to include this library. The next thing is to define the main function, which is also the same in C. And then you need to use this syntax, std, cout, and then hello world. Let's break down this line, std, semicolon.
Is there any meaning to std count?
Yeah, we are going to explain why. Hello world. Oh. Yeah. Let's start from cout. Cout is like if you used in C, you have a function called sprintf or printf. Sorry, printf. Do you use printf before?
Yes.
Yeah. So cout is almost the same. The functionality is exactly the same. You can use this to print your messages. So cout is, you can think of it like printf. But instead of printf, we have a cout in C++. In C, you put the message inside the arguments in printf, right? In C++, for cout, you need to have this operator, which will direct this sentence to the cout to print it out. So whenever you want to print anything, you need to put cout, then the operator, which is two smaller or bigger sign, and then your message. Any message you want, here, the message. And later when we'll get advanced step in C++, we are going to explain how we are using this operator with this function. You can say function for now. How we define that this operator is going to be used with this cout. So you cannot, for example, you cannot say cout brackets or arrows, and here put your message. Okay? It's not allowed in C++. You need to put it like this, in this format. Cout, the operator, and then your message. The STD, we are going to know what STD means later in the last slide, last two slides. We are going to explain what means of STD. But briefly, just to give you an introduction, STD stands for standards. And this is you can think of it like C++ has some of its own functions, and once you want to get an access to them, you need to write STD and the operator, and then you define what you want to use from STD. So you can think of STD like a group of objects and functions you can use from inside the C++. So STD is the standards inside the C++. So once you want to use cout, you should define that this cout is we bring it from STD. Okay? Yeah, but it's not a library. It's a different thing that we are going to explain. And the operator we use here, the two smaller or bigger sign, is called the insertion operator. Because again, I mentioned that we redirect this sequence of charts to the cout object. Actually, cout is an object. Again, we said that C++ is mainly an object-oriented language. So mostly everything is built around classes. And cout is an object of a bigger class, let's say. And we use this special operator to say, look, this sentence will be your message to put it for the user, to show for the user. And this operator, we call it as insertion operator. And just in context, or just when we use it with cout. I mean, when you see this sign, it's not. There is no meaning to call it insertion operator. Just when you put cout before it, it will be called an insertion operator. Is it clear? Yeah. So please now open Google Colab. You already open it? Yeah. You make a new file. Yeah, a new note, yeah. Yeah, okay. Before we start like building our first program, any language, you start by writing the source file, right? But source file is just like words, syntax. You need to convert it to an executable file or .exe file. So in C++, it's like any other language. You need to use compiler. And compiler is the thing or the tool you use it after you write your syntax to convert it to what's called object file. Okay? So when you write a file in C++, it has the suffix of .cbb, and then once you call the compiler, it will be converted to .o file, which is an object file. The last step is linking, which converts the object files you have to an executable program. So this is the process of building any source file. And we are going to see how we do this practically for C++. So you already opened the Google Colab. We are going to use this Google Colab as an, let's say, cloud IDE or integrated development environment for us. Because actually Google Colab, I don't know if you heard about it before, it's used for Python. You can write your all code inside the notebook you already opened. But it's also can be used for C++ because actually Google Colab gives you like a virtual environment in the background or in the server side. You have like your own environment. You can access to compiler. You can access to even to your Google Drive files. So it's like a small version of small operating system for you. It's not good to say this, but if we want to simplify what is Google Colab, you can think of it like you have your virtual environment, which has tools, compilers, and different things for you. So for today, we are going to write our program in Google Colab and then compile it and then run our first program. But first, we need to interact with the compiler or to your virtual environment, which is, again, it's like small OS for you, if we can say so. So we have like commands. We should put it in each cell. The block you see called cell. So this is a cell. For instance, the block is called a cell. It's just a term. It's not a programming term, just the term related to Google Colab. Inside the cell, you should say that the content of this cell is going to be written to the file called test.cpp. Because again, you don't have like a GUI. You don't have access to your own virtual environment using mouse. You need to use commands to make it do what you want. So these commands, once it starts by the percentage sign, it's called magic commands. So there is no need to understand what they do, just you need to memorize or to know how to use it in Google Colab. So it's not required in assignments, math, or in the exam.
Yeah. Or include I will.
But it's not the source file starts after this sentence. So when you say write file test.cpp, the source file starts below this sentence. It will be not included in test.cpp. Okay. So let's start by the first cell. You can write file two percentage signs. Write file test.cpp. Yeah. Enter. You can press enter, and then you can write the program. Include. Don't use stdio. Use IO stream. You can write the same. Yeah. You can use this. Yeah, you can write this program. IO stream. Yeah, and then int main. std. You can write it all, the whole program.
No space, right? std.
Yeah, no space. Yeah, and return 0. You write. Yeah, everything. Yeah. Okay. So next, now press Shift Enter, or you can just press. There is a run sign. Yeah. Okay. Yeah. Okay. So next thing is now we want to execute or to call the compiler. The compiler used for G++ is called G++. Sorry, for C++ called the compiler called G++. So the name of the compiler is G++. So first thing you need to also to make Colab understand that this cell will contain a command line executable command. So you need to write first 2 signs, percentage sign shell, then G++.
Minus 0? Is that minus 0?
Minus O. There is an error. You can check the error. No such file.
High 3 plus.
Okay, so it's done. So to understand what this means, G++ is the executable file of compiler. So this is the compiler exe, let's say. So you have, if you want to try it at home in your own local PC and you install the compiler, you will find G++ exe file. So you are just calling, you use CMD, right? Yes. CMD on Windows, yes. Yeah. So it's just a command. And then you specify the file you want to compile. This is the file you want to compile. And that dash O is an argument for this compiler file or compiler program. So you specify by dash O the name of the executable file you want to have. So you can name it anything you want. Okay. So this is the executable file, and that's why you can see here, like the second line is ./test. So the produced file by this command, first command, is being called by in the next line, and that's why you see here hello world. Is it clear? Yeah. And by the way, I think the backslashes is in reverse or direction. You need to use the other one. That's why you. Is it okay? Yeah, now it's okay. Should be okay. You should execute again the cell, run the cell by Shift Enter. Yeah, and then run again the following one. Yeah. Okay. So congratulations for your first C++ program. To prove that C++ support also the C, you can duplicate the cell you already wrote, and just remove the C out and just use printf.
Include
Yeah, and include change it to stdio.h. But I think to have more time to cover other slides, I think.
There is no need to write file.
Sorry, what?
Write file.
No, it's you should, yeah, but you should change it from .cpp to .c.
Okay.
Yeah, but you can try this at home just to save more time.
Okay.
Yeah. So this is just an proof that you can already use anything in C, in C++. So let's start now exploring and review the old concepts in C and C++ because there is no like separation between C and C, good separation between C and C++. So some of these concepts, it's identical to C also. So it's good to review all concepts. First of all, comments. Once you want to enter any comment, I think you already know this. You do the double slashes and then write your comment. This is if it's one line. If it's multiple line, you should backslash star and your multiple line comment and then star and then backslash. First thing, the identifiers. Identifier is like naming your variable or naming any new object and any new item you have in your program. So you have like a set of rules you should follow while naming the variables. So first of all, you should use letters and digits, but this is rule number 1. Rule number 2, digits cannot be the first letter in your variable name. So, for instance, variable 2 cannot be written like 2 variable, just like this. The first letter or first letter in the variable name should not be a digit, should be a letter. You cannot use space. You should use, if you want to have like separation, you should use underscore. Variable names is not identical if you use upper letter with small letter. So let's say variable name here is in V capital. If you change it to V small letter and variable name 2, it will be a different variable. Like here, var and var with capital V. And you cannot use also reversed keyword. So you cannot say your variable name is int, for example, or float or double. So you have set of keywords which is defined in this table. You can check them later. You cannot use any one of these keywords. The other thing is including or inclusion of any source file you want. As you know, you use the include, the include, which is called a preprocessor directive. Anything start with hash is called preprocessor directive. So it's not just include. There is, for instance, also define. And also it's found in C. So if we want to define the constant pi equal 3.14, so you can just say hash define pi and 3.14. And once you use pi in your code, it will be defined as 3.14. Okay, so I just want you to add define in your code. You already made a code. Just make define.
Next or?
Yeah, you can change the same code. Just add define lang, stand for language, and let's say tr. You can use tr as
again bracket file.
No. In the same cell.
Okay.
Yeah. Just in the here, you can make hash define lang and specify as the tr for Turkish.
I meant Turkish.
Yeah, tr. You can use tr. Yeah. Now just copy and paste the cout hello world. Another. Make it another. Just this line.
This line.
Yeah, copy and paste under this line also. Just make a new line under. Yeah, okay. Yeah. Paste. Yeah. Change hello world to Selam Dunya or any. I think this translation is correct, right?
Mm-hmm.
Yeah, you need to, once you want to use define, for instance, this is one of use cases. If you want to have like one code, but you may have different scenarios in execution. Let's say you have like, you need to print the welcome sentence to the user in different languages. So you can use the define and select your language. It could be Arabic, Turkish, English. So if you want to tell your compiler which sentence is going to be used now, you use define, and then you examine, you check the content of language or the value of lang with the if directive. Yeah, but this if is not like the if used in the normal. I mean, you have like a sorry, in the control flow control in C. You can use if and else, right? You remember
Yes,
them?
if,
Yeah,
yes, if and-
yeah. This is as the if I mention now in if and else is it's going to be executed in runtime. I mean after compilation, it's in runtime. Okay, so for example, in this case, you should enter. Let's say you print for the user first. Enter your language. So user enter from the terminal. It's Turkish. Based on this, your program will check the value entered by user and print the message to him. But in this case, it will be in the compilation time before execution. So I will prove to you how this. So first of all, make hash if lang equal to tr, or first one is English, I think, in your program. No, tr. I think hello world is. You can define the line at compilation time. So if you used, let's say, if we don't have a problem and you used English and here put it any like error, it will not be detected by the compiler because it will not include in your program, the program you compile. So you can add any error to it and you can check it. But let me see why later, see what is the problem here. The variable types in C++, we have different or many types, but we are mostly going to use like float, double, integer, char, bool for boolean. I don't know how to which level you are familiar with these variable types. Not too much. Yeah. The difference between each one is, first of all, the size of the variable. So you know, in computer we have a memory, and each variable has a location in the memory, right? So some of these variables allocate 8 bits or 1 byte. Some of them 2 bytes. Some of them 4 bytes. For example, a char use 1 byte or 8 bits, as this table indicate. For integer, it takes at least 16 bit. For long integer, take 32, sorry, or 4 bytes. Long takes 64 or 8 bytes. For pool, takes 1 byte also. Boolean, that's how to. Yeah, char. This is the first difference is the size of the variable. The second one that you use for each variable type is suitable to a value. For instance, char is used with the chars as the name indicates. So char C equal, for instance, A. So this one, once you have like a variable you want to be a character, so you need to use char. If you have a number without floating point, or without as an integer, you just make int, let's say n, your number. when you want to have floating point.
Sir, I know float, char, voids.
Ah, you know it, yeah.
Yes, but I don't know
Yeah.
char 16.
Yeah. These mostly we are not going to use, but these variables, types of variables are available in C++, but we are not going to use. Yeah, mostly we use just the common one.
Float, I know.
Yeah. So if you know it, it's good. Yeah. So this is just if you are already know the variable types, this is like explanation how to use different variable types: integer, chart, float, boolean, or bool, and you can copy the size. So you can try one variable. For instance, you can define float variable. Yeah, and you can just make Ctrl Z and remove the, sorry, here. Okay. And then print the size of it. You can check the size of the variable using this built-in command size of.
Last one is L.
End L, yeah. Here end L is, in the first example we used /n to make a new line. You know the /n as a special character?
Yes.
Yeah. In C++ there is another way, which is when you use cout, you can either add /n to the text, or you can use the end L, or its stand of end line. So if once you put std or end L, you have a new line.
So is it correct?
Size 4, yeah. So float takes 4 bytes. It returns the size of the variable in bytes. Yeah. Yeah. So do you know also the difference between signed and unsigned variables?
Not at all, because the complaint Jenkins learned from.
Okay.
I have no time.
Yeah. Simply like all variables you can define it as signed and unsigned. I mean, like if you have integer var, let's say equal to 10, in your program you can make it, you can say it's -10, right? But in special case, you want to use the whole size of integer in the memory with positive numbers only. In this case, you should make it as unsigned. Just you put unsigned before the variable name, and you use it only for positive numbers. So integer if you take 2 bytes, it will be dedicated only for positive numbers. If you remove, if you remove it or add it signed, by default it will be signed. For integer, by default it will be signed. The space will have the 4 bytes will be able to have positive and negative. But what the difference between signed and unsigned? I don't know if you took already the representation of numbers in different numerical representation, like in binary, hexa, not ASCII, no, binary, hexadecimal.
We just all learning.
As an overview.
Just one lesson.
Okay.
Quickly.
So for example, you know, like binary of
Kind of.
yeah. So let's say if we have this number 0, 0, 0, 1 in binary, you know how to convert it to decimal?
No.
Yeah.
I don't know.
Yeah. Okay. So this is called binary representation of a number, integer number. So 10 is just 1, 0, 0, 1, 0, 1, 0, because in binary here this has the value of 1, this 2, this 4, and this 8. Actually, it's hard to explain if you did not took the numerical representation, binary and hexadecimal. So we can skip it, but just to know, bit you already know what bit means. It's the smallest unit in the memory. So when you want to differentiate between, let's say, you can take it as a fact that 10 representation in bits is the same, which is 1010, okay, in bits. But how to differentiate, to make a difference between plus and minus, you use the last bit as a sign. Like when we write on paper, how you know this is negative? You have a sign, right? So you can use the last bit as a sign for. So once it's the content of the last bit is 1, you know that the number before the 1 is negative. And if it's positive, you just put it as 0. Okay? So this is the difference between signed and unsigned. Now you already mentioned ASCII, so you know ASCII. I think so. ASCII is like when you for computers, they only knows zeros and 1, right? So how to store a character inside the memory, really? If you have memory, you have only bits. So how we usually store a character? We use ASCII. ASCII is like the numerical representation of our letters or our alphabet. And it's famous because each, like here you have in red, you have the columns of the characters. For English alphabet, each letter has a value in decimal here, decimal. This is the value of the character. So A means in the memory, it's 65. You store it as a 65. It's not an A. You cannot put A inside the memory, right? So this means the ASCII. Even the numbers. I mean, when you have like a message you want to print for the user, let's say A1. This one is not the integer one. It's not the decimal one. It's the one found in the ASCII. So you can find 1. Where is it? This one. 1. It's 49. Okay? So this is 49. I mean, if you want to see it how it's stored in this sentence inside the memory, A will be the 65, and 1 will be the 49. So this means this is how we store charts in the memory. Now I want to prove like how ASCII works. Let's say 9, like you have like sequence of charts. Like you start with 0, 1, 2, 3, 4. 0 is 47, then 49, then 50. So how you usually convert? If you have a like variable in your programming, if you have a variable called a char c equal 9, and you want to make multiplication or addition to it, how you can convert it to the decimal representation? Because 9 from this table is 75. So the variable of c inside the memory is 57. Sorry, it's 57. So how you can convert c to a number and then add a number to it, another number, or make a multiplication to it? So do you have any idea how to do this?
No.
Converter, yeah. So basically, this is a rule. Once you want to change a number in ASCII to a real number or decimal value, you just make a minus with 0. But in a new variable, let's say let's put it in another line. Let's say integer n equal c minus 0 in ASCII. Okay? 0 here. What's the value of 0 from this table?
Char 0.
Yeah.
48.
Yeah, correct. 48 minus C here is 9. 9 is 57, right? So 57 minus 48 is 9. So this is how you convert a char to a decimal or to a real number. And this is the program you do this. We have the same program we already explained. Declarations and definitions. This is a term, important term you should learn in any language, especially in C++. You have declaration. You declare for inside your source code. You have like a function. For example, is odd, a function to check if this number is odd or not. You just declare it. You say that in this program, there is a function called this. But what this function do, you should not include in the declaration. You include the functionality or the source code of your function in the definition. So you have two different terms: declaration and definition. All the time, declaration has no. You have no source code. You have no. You don't have the implementation of your function. You just say I have this function which has the x name and y value as a return, like here boolean, and has one argument, two argument, and each argument has a set of and each argument has a certain data type. Do you want me to skip this slide, or do you want to have more explanation?
No.
Yeah, it's okay. Arrays, it's almost the same of C. You can, arrays, right?
Well, I wasn't good.
Yeah, okay. Arrays simply like, I think I have a graph in the next slide. Yeah. Let's say we have like this. This is a memory. Like memory is just a locations, and has certain size, right?
Yes.
Mostly divided into bytes. For simplicity, it will be divided to bytes. So if it started with this is the first address, this is the second address. We start counting from 0, right? And then until n and n minus 1. So an array is just when you define a sequence of items, of sequence of numbers inside the memory in sequence. So let's say if we make a picture or if we scan the memory and we have the following content. Here we have 1, here we have 10, here we have 5. If we want to tell our program to allocate these addresses with these values, 1, 10, 5, you simply say in the program, integer, let's say if these values are decimal, so we can use integer, and we use the name, let's say stand for array, and then you put the size. Here we have how much numbers? How much? 3. And make brackets and put the numbers here, like 1, 10, and 5. So simply this is the array. You store the values inside the memory in sequence, and you specify the value inside the declaration and definition of your array. So you simply this is the type of the array, the data type. So all items will be integer. This is the name, and this is the size. So this an array of 3 items, and each item has the type of integer. And this is equal. If you want to oversimplify, instead of your program has like integer array 1, integer, array 2, integer, array 3, instead of defining 3 variables, you can just combine them in one variable and call it as an array. Okay? Let's move back. So again, this is another example, array with 4 items, integer, and stored in the memory, in the addresses. But again, the address, it will not be 1, 0, 1, 2. It will be something realistic. Even this one is not realistic. But anyway, you should know that the address in the memory will be increased by the size of the item. So if you have integer in C++ is 4 bytes. So the first item, if it starts in 1000, the next address will be 1004. Because you have 4 bytes. Is it clear? Yes. Yeah. The next one will be 1008, 1012, and so on. And this example is exactly what you tried to do, but using a for loop. You know for loop, right? Yeah. So here we just print each item inside message using a for loop, and we make it starting from 0 to size of, and size of is, which gives you the size of the array in bytes. So here will be from 0 to whatever, how many length, 4 to, I don't know, I don't remember. It will be from 0 to the length of this message. Okay, and you have also option to declare to the variable by just making adding 2 indexes for the variable. So you have like, if you want, you know matrix in algebra?
Yes, kind of.
Yeah, so if you have a matrix for like 0, 1, 10, 5, 6, 10, 0, 0, and you want to store it in a program, so you just simply define here a variable with, let's say, integer, matrix. Here, what we should use as numbers here inside? What is the dimension of this matrix? How many rows and columns? 3 by 3.
4.
No, 3 by 3.
Yes, 3 by 3.
Yeah, so here you add the size of rows, and here the size of columns. So whatever you have, any matrix you want, you simply add here the number of rows, and here the number of columns. Okay? This is an example of multiplication of two arrays with size 3 by 3, as you can see here. Array 1 is, can you tell me the array 1 content, how it will be? If you want, like, write it inside the mathematical way.
303?
Yeah, the array 1, ARR1. How it should be like here?
I don't understand.
No, I mean, like, we have this in the program. If we wanted to write it in algebra as a matrix, how it should be? Like, if you wanted to write it as in, like, an ordinary matrix on paper.
2, 3, 5?
Yeah, correct, 2, 3, 5. Then...
And under the 4, 5, 6?
4, 5, 6.
And 10, 1, 0.
Yeah, that's correct. That's correct. So this program multiply this matrix with the second one, which is 1, 0, 0, 1, 1, 0, and then 1, 1, 1.
The 0, 1, just all the rows and columns is 0?
Which one?
Last one, 0, 0, 0, 0, 0, 0, and 0, 0, 0. Last one, array 3. Array 3.
Okay. This one will we will store the result inside the array 3. So in this case, we just initiate or initialize the array with value 0. So when you want to store the first state or the initial state of any variable, if you want to use it as a result, you should say it's 0 directly. So this means that all the items inside the matrix will start with value 0, and then you use it while calculating the result later. I will not explain how we do this program. I think it's out of scope of this session, and it's not what we're going to learn in algorithm. You can read it. I think you should already did something similar in programming.
We did rectangles
with
symbols.
Yeah. So just it's an example for refreshing your information. The pointers. Just let me correct the. This is better. I think you already also used pointers somehow. Yeah, the pointer is simply when you want to deal not with the variable directly, but with the address of the variable. So let's say we have another variable, simplify the thing. Let's say this is the variable of int a equal 5. Okay? The address of this is 2. Let's say simply is 2, or let's make it more realistic. Let's say this is starting from 1000, 1004, 1008. So if we want to access A, but not directly, using the address, we have a pointer, what's called pointer. Do you know how to define the pointer? Yeah, it's just adding the same data type with a star. Once you add star, this means that you have now a pointer. Let's call it PTR. If we want to have the address of this variable, we should use operator which is AND. Once you have like AND and the variable name, this means that it will return for you the address. So this actually equals to 1008. Okay? Yeah. So now the pointer is pointing to variable A, which is in the 1008 in the memory. So if you want to deal with pointer and to change the value of A without accessing, if you want to change the value of A in the simplest way, you just say A equal to, let's say, the new value, 10, right?
And 1004.
Yeah, and this will change in 1008 to 10 directly.
Oh, the value is not changing, the pointer is changing, the 10.
Yeah, then the content of the memory will change, but the pointer will still pointing to 1. Okay, let's remove it. The other way, do you want anything?
Yeah, what?
Yeah, do you want a break or something?
No.
Yeah, okay. Okay, so the other way, without using integer A, using PTR, which is pointing to this address, you simply, when you want to use the content of the address that this pointer point to, is this sentence clear or? Yeah, I will repeat it. If you want to use or to change the value of the address that this pointer point to, you simply add star, another star, and then the name of the pointer, and then the new value, sorry. So this equal this equal this in functionality. Both are the same. So if you execute this will be changed to 10, And if you execute this, this will be changed to 10. Okay? We will find later the application of pointers. This operation called dereferencing. Once we change a value of a memory location using a pointer, not the original variable, we say this is dereferencing. Okay. I think this is enough for pointers. Actually, I intended to explain this example, but as long as you don't have background in hexadecimal, let's say. Do you know hexadecimal or no? No. Okay, so I cannot actually explain this example. Okay, so let's skip it. The other thing also good I think we were going to use in this course is type diff. Let's say we don't want to every time. Let's say if you have a pointer, how to define a pointer from char?
Pointer sign.
Yeah. What we should write to define a pointer to a char?
Are we going to use pointer sign?
Yeah, the pointer sign is the star here. Yeah. Then PTR. If we don't want to use every time char star, we want things to be simpler. We can say simply in our application type diff char star and say give it any name we want, char underscore BTR. If you did this, if you have this in your program, you can replace the char star with simply char BTR BTR or any name, any variable name. Is it clear?
Yes.
Yeah. And actually, you are going to see this, maybe not in this course, we may not use it, but in many applications, you may see like something like this. int8 underscore t or uint8 underscore t. This is famous variable types, almost used in too many programs. And this is nothing more than type diff unsigned char. It's very used in too many programs. When inshallah when you graduate and start real programming, you may use this type a lot. Why they use this instead of using unsigned char? First of all, char we agreed that char how many bytes in char? 1 byte.
Yes.
1 byte. So, and unsigned, as explained to you, this means that you only want to use positive values. So, instead of having this long words, you just define a new type with int8 underscore t to replace this unsigned char. Okay. Or this one is for you, int. And the other benefit of this, the 8 means this 8-bit. So you don't need to memorize every time that if I want a variable with 8-bit, I should use char. If I want a variable with, if I asked you, which variable we already see that takes 4 bytes? Integer. Yeah, it was integer. So, for example, now you forget the value. So instead, you simply say it will be already defined unsigned integer 32 underscore t. Okay. So this is 2 benefits of using such way of defining new types using the keyword type diff. Also, we have, if you don't want, this is also, only available in C++, the auto keyword. If you don't want to specify that this variable will take only integer, let's say if you have like setting or a thing that you may change in your variable. Let's say if you have any constant you're going to use in your program. Let's say CNT equal a value. This value may change. You may change it to any value and then run your code, compile your code. It could be 2, or it could be 2.5, or it could be too much, a very large number, whatever number. Instead of like changing every time manually the value, here for instance will be integer, here will be float, here will be long or long, whatever. Instead you can just replace all these with auto. This means, as the name implies, auto means automatically the compiler, depending on the initial value, it will say, oh, this is 2, so it should be integer or it should be char. But you should be careful, like you are not misusing this feature, and you expect like it should be like float, and you expect that it's float, but you make the initial value as 2, but in this case compiler give it as integer to you, but you assumed in the other places using this variable that's float, but the compiler decided it's integer. So you should use it wisely. You should know that if you want float, you should put it 2.5 or 2.0 at least. Okay. This is the operators used in C++. It's the same of C. Addition, multiplication, the increment. You know the increment, double pluses. It's almost identical to bitwise operator. I think we will not use it in this course, so it's not too much important as long as you don't have a background in numerical representation. These operators, I think, is also known for you. The logical one inside the ifs. Yeah. Let's take a 2 or 3 minutes break, just refreshing, and then let's continue. This slide is just to understand how you have priority when you have multiple operations inside your program. Let's say if you have a variable, let's say you have already variable with A, B, C, and D, and you want to check this condition. If this sign, what does mean? Or. Yeah. B and this is logical and C or D. So do you know how this will be executed? I mean, which part will be executed first? How the program will execute? I mean, first it will check this operation, and then or like this.
The or sign you have to check, and
then and. Actually, it's in reverse, because in C++ you have like priorities. Once you have like too many operations, there's something called precedence. So starting from precedence 1 until 17, the first one is the highest priority and 17 is lowest priority. Okay, so let's decompose this this operation. We have and we have or. If we went back to the table, you can see and is 14 and or is 15. So first thing it will be executed is and then will be the D. So first thing will calculate B and C, and once it's done, you have, if this done, you have and or the result here, or the result or D. Here we have how many operations? Two, but both of them are the same. Yeah, but both the same, I mean the same type. So you can see 15 is the logic OR, and here finally say that associativity is from left to right. This means associativity, when you have only the same operation in your line of code, it will be starting from the left to right, like this. Okay? So first we'll make A and the result, and then the new result with the D. If we want to make it more complex, let's say the increment, pre-increment, y plus 5. You know this operation, star equal?
Yes,
Adding to the same value, to z, yeah. So if you want to decompose this according to the table, can you help me? Let's first define the operations, right? So we have the first operation, this. What is the priority of it? It's 16, here, 16. And we have the increment is 3. And the addition, it's in, where it is, yeah, 6. Yeah. So first will be the addition, as you said. This is number 1. Let's make it squared. And then the addition will be number 2. And finally will be the 16. And this is important because sometimes you may get a bug to expect that this will be like the past example. You said no, it will calculate C and D, C or D, and then A or B, and then make the logical AND. So sometimes this make a bug for you. So it's good like practice. If you fear of having a bug or something like this, if you actually want, as you said, if you actually want to have this executed first and then the whole two sides we make and the logical AND for them, you just add this priority for them using the using the brackets. So and you can see this has high priority from, where is it? Actually, I can't find it in this table, but actually in this way you tell the compiler that you should do this and then this and then the complete term calculated with the AND, logical AND. So once you have any doubts or you have any suspicions, you just add them to be clear how this will be executed, or you just you should memorize or make sure that it's correct as you want using the table. The control flow is the same of C. You have the if else, switch cases, you know, right?
Yes.
The for loops or iterations, while, for, do while. For the jump statements, break and continue inside the for if you want to break the iteration, and go to, which is seldom used. Actually, this is an interesting thing that when you want to execute a program, sometimes if you use CMD, you see like we already see that G++, we wrote G++, and then the file name, right? The test.cpp, and then -o, and then test. This is, as I mentioned, this is the program, and this is the arguments. So how we deal with these arguments inside our program? From the CMD side, we just put like this, but inside the program, how we can deal with it? This is something not related to algorithm for sure. I think you will not use it, but it's nice to know. You just add to main inside the main. You add argc and char star argv. In argc, you have the counts of your arguments. So for a program like this, test arg1, arg2, it will be 3 arguments. They consider the first, the program name as argument, but actually you have 2 arguments. And the argv, which is an array of charts, array of pointer to charts, will have the value of your argument. So if we printed number of argument here in our program will be 3, and argument 1 will equal to the value you specified here, and argument argv, as you can see here, argv2, because in total 3 arguments will be arg2. Okay? So I think it's nice to try it at home. You can try it, by the way, on using Google Colab, the same. So just you modify the test. If you see from the cell, second cell, you just make ./test. So you can just add the argument you want, and add argc and argv from the Euro program, and you try to print the arguments. I think this one is going to be used mostly in the course, called function overloading, and this is only found in C++. This means sometimes you want to, let's see the example here. If you want to have the same function name but with different arguments, or you want it to use it with different arguments, but you want to have the same name. I mean, for like print. Actually, you want to print. Sometimes you may want to print a number, integer number, or you want to print, let's say, a message, or you may want to print a float number.
Yes.
Each one of these has a special way to print for the user.
Yes, sure.
But in C, you solve this by defining a function with a new name,
Yes.
a different name. So this one you may say it's print underscore integer, this print char, for example, this print float. This is in C, but in C++ you have overloading. If you know the term from English, overloading means that,
Yes, pushing so hard.
yeah, on the term. So it's used like this also in C++, because you use the same name but in different context, in different definition. So as this example show you, for print integer, you say int has value blah blah blah, or the double has value. And how compiler know which one will be called? It's using the argument. So two things can say which version of your function will be called: the value, the data type of your argument, or the number of argument. Because you may add another definition for print that takes 2 arguments, let's say. So it's up to you, but this is the a function in C++. Namespaces, yeah, this is actually important. Just I think we have just 3 slides left. If you remember, we have like std, columns, 2 columns, cout, right? And in the beginning, I said to you that you can imagine this like space inside C++ that has definitions or functions specified for C++, defined by C++, and we called it std, and this is standard. Actually, the name of this term is not the std. I mean that the way of using this is namespace. What this means, like your program, you have functions. So you may have like void, print. You have like a variable, let's say int var equal to 0 or anything, and you may reuse these names, right? I mean, you may use another in another context, another int var. Usually in C, if you use 2 int var, you will have what? An error.
Yes.
Because you have multiple definitions, the same variable name. To solve this, C++ added space name. So you simply add namespace. Here you add the name, and you just close it with a bracket. So like this, you have 2, let's say, persons, Mike and Fred, and each one has a function inside to initialize the person. So like we said, namespace, Fred, brackets, and then you add the function you want. And instead of adding different names, you should just add the same function name, initialize, inside the namespace, and then you close the namespace. Now inside the function, the main function, or inside any time you want, you use the initialize, but for Fred, you make Fred the 2 columns and then initialize. In this case, the compiler or your program will call the function for Fred. The same thing is for Mike. So this is simply the namespace. Is it correct? Is it, clear? And I know it's too much, too much terms, but yeah. It's good to go home and try this program on Google.
I will buy a course for Udemy for home.
Yeah. Actually, there was 3 exercises, but the third one was depending on having knowledge on numerical representation. So you are asked to solve these 2 exercises. The first one is to, as I explained, the ASCII code. You need to, you can start from this program. The places you need to add from new words or new program is inside the comments. So I just want from you to convert the capital letters from A to Z to small letters, and just remove the comments and add your program, and then submit it. The second exercise is doing 2D matrix multiplication, and you already said that you have knowledge to do this.
So, but what is it like? I don't know. Math 1.
Yeah, it's just a mathematical representation, just mat1, R1 multiplied by C1. I mean, the dimension is R1 multiplied by C1. Could be any dimension. I mean, the slides, we have like example 3 by 3. Like the matrix was, like if you have this matrix in algebra, if you have this matrix for 5, 6, 7, 0, 0, 0, you say A 3 by 3, right?
Yeah.
So mat 1 is matrix 1 with the size of, you have row and columns, right?
Row 1 and column 1.
Yeah, so it's the size of matrix 1 with this number of rows and this number of columns.
And mat 2 is
And mat 2,
columns and 2.
not 2 columns, it could be any number because you are going to ask the user to enter the dimensions.
You want the size of columns.
The size of columns, yeah. I mean, first of all, you say enter, you print this to the user, enter the matrix size. And the user enter 2 numbers, let's say 3, then space, then 3, for example. So you consider 3 is the row number of rows of first matrix, and 3 is the number of columns for for the first matrix. You repeat this for the next matrix also, and then you find the multiplication for 2 matrices. You also need to enter the values from the user, so user will enter 3, 4, 5. So if you have 3 by 3, you will have total 9 items inside some matrix. If it's 3 by 4, it will be 12, right? So you should check this. And you know, when you multiply 2 matrices, there is a very condition to make the...
Oh yes, A1, B1.
Yeah, I mean, you can multiply any 2 matrices, or should we have like a condition? You can multiply any 2 matrices? No, it should be column 1 and number of columns of first matrix should be equal of number of rows of second matrix. This should be equal. I mean, like, if the matrix M1 size was 3 by 4, okay, and matrix 2 is 5 by 3. This will, you can't find the solution for this. Because if you went back to how to multiply 2 matrices, the same number of columns in first matrix should be the same in the second one, and the same rows of the second one. So it should be 4. That's why I added a note here, through an error or print an error using an assert. And assert, you should search for it, how you use it. If C1 like from the C1 not equal to R2. So after you print two lines to enter the dimension of first matrix and then second matrix, you should compare the number of columns with number of rows between matrix 1 and matrix 2. If it's not equal, you just break the execution and say there is an error. It's not correct to do this. Is it clear? Yeah. So there is 2 things you need to self-learn: how to use assert and how to use the input from user. Okay? I think the exercise 1 is easy. Exercise 2 need a little bit of attention. We are going to use Google Class to upload your code. This is required from the university. It's up to you, actually. Actually, personally, I prefer to use GitHub. Again,
again read me MD file to code my code.
If you want to upload your code, no, just simply add a new directory.
Can I use Visual Studio?
Yeah, you can use anything. You can use anything for the code. But when you upload it for GitHub, you can use anything. When you want to add it to Google Class, just copy paste the code and add it to TXT file, just for simplicity. Okay. And deadline is for the next session. Okay. Okay. Thank you. So do you want to use GitHub or just give up?
I can use GitHub.
Yeah, it's up to you actually. Again, I chose GitHub just to learn new thing. It's a practical thing, not related to